All right, so this is a walkthrough on how to linearize the data from part 2 of the Simple Circuit Lab using LoggerPro. And this is assuming that you already have all of the data put into LoggerPro. So I don't have to take you through those steps. So here's my fake data that is already put into LoggerPro. You do want to make sure that you've titled your column headings here, and knowing all of you the way I do, I'm guessing that many of you haven't. So over here on your X variable, your independent variable, I want you to double click on the top, and you're going to label, put the name down, which is resistance, and in the name. And then the short name is the variable that would be used in the mathematical model. So that's going to be capital letter R for the short name. And the units are ohms. You could write OHMS, but it's almost easier just to click on this drop-down menu and go to Greek upper, and it's the very last one here, ohms, right here. So click on that, and that way you get to see the cute little horseshoe with feet and use that. So that's going to be for the top of the x-axis, and the y-axis, you're going to double-click and type in current. And then the short name is capital letter I. Again, that's the variable that they're going to use in the equation. And the units are capital letter A. So you're going to do all of that. Once you've got that, you've put a linear fit on here, and you can see, if you look at it closely, you should see that it doesn't look so good. If you ran all the statistics, I'm not saying you need to, but your RMSE is going to be pretty big because you can see how far off the line a bunch of those points are. And the over-under test is really one that makes sense, that should have bells go off that say, oh, this really looks like maybe it's a curve. So if you look at the data points, we have a data point up here on the top that's over the line, and then we have 3 data points under the line, and then maybe 4. This one's kind of a transition point, and then it goes back over the line over here. Sometimes you can miss this point over here on the edge, but so it goes from over to under to over, and if you look, it does look, whoops, I didn't mean to do that, it looks like it's a curve. So if you look at the shape of the data, not the line, but the shape of these of the dots of the data, it should look like it's a curved line. And so then what you want to do is open up and look at your blue sheet and find out what relationship is that. So if you go to your blue sheet here, this isn't blue, but the blue sheet would say graphical method summary, and it is going to be linked at the top of the assignment, although you can just look at it here. Notice the first column is the graph shape, and that's what you're going to want to look at and see if you can figure out the shape that your data points are giving you. The second column tells you what the relationship is. The third column is how you linearize it, what you need to do to make the graph linear. And then the fourth column is what it would look like in an algebraic mathematical model, basically what it looks like as an equation. So if you go down here, some people want to say that it looks like this fourth line right here, because it does look like the linear fit you put on it, which is a negative linear relationship. But that's the line, not the dots. The dots, if you look at them, they are actually in this kind of curve shape like this, which is an inverse relationship. And I'd like to say it best, the y is inversely proportional to x. Now this third column here tells you what to do to linearize. And so it's saying right here, replace x with 1 over x. So it says basically that you take whatever's on the x-axis and you're going to replace it with 1 divided by whatever is on the x-axis. So if we go back to our LoggerPro, let me just minimize this. If we go back to our LoggerPro, our x-axis is resistance right here. And so we want to, instead of using resistance, we want to do the inverse of resistance, which is 1 divided by the resistance. And we could go and do all the math for ourselves and put in a new column and do it, but it's really pretty easy to make the computer do it for you. So in order to do that, what you're going to do is go up here to the data column right here, the data menu, and click on it. And then about 5 from the bottom, it has new calculated column. So you're going to click here on new calculated column from the data menu. When you do that, it says, well, what is it that you want to call this new column? And we want to call it inverse resistance, because that's what it is. It's the inverse of the resistance, which is, again, 1 over the resistance. So I typed out inverse resistance for the name. And then for the short name, that's what goes in the mathematical model. And resistance is capital letter R, so inverse resistance is going to be 1 divided by capital letter R. And the units of resistance are ohms, and so the units of the inverse resistance is going to be inverse ohms, which is 1 divided by, and then I'm going to come over here, click on the drop-down menu, go to Greek upper, and then go all the way down to the bottom and choose the omega ohm symbol. Then I'm going to click down in this expression box here. And this is where I tell the computer how to calculate the numbers that I want the computer to make a whole new column, call it inverse resistance, and then I want the numbers that go in the column, I want you to take the computer to take 1 divided by, and then the values for resistance. So I put 1 divided by in my expression, and then I'm going to come over here to this button here in the middle that says variable columns, and that's basically, if I click on it, it shows me all of my data columns. And so I want to choose the resistance column, and when I click on it, it puts it right in there exactly how it should look, 1 divided by the resistance. And then I'm going to hit done. And now I'm going to hit Control R, or click on Control R, so you can see all 3 of the columns now. So I've created that blue column right there, 1 over resistance, and the computer went and took the value of resistance, did 1 divided by that, put it in my new column. And so that's the easiest way to get from resistance to inverse resistance. So now I need to go over to my graph, and I'm going to go down to the resistance down here at the bottom, and I'm going to click on it. I'm going to regular click, left click on it, and I'm going to choose inverse resistance instead of resistance. And then I'm going to right click and auto scale from 0, because you can see all the data points are all over here, because I've went from really big numbers to really small numbers. So I'm going to right click and auto scale from 0 again. And I can get rid of this linear fit box because that was the old one. And so if I can find the little X, I will exit out somehow, get there eventually. There it goes. And now you can see that I've definitely got a little bit more linear relationship. And when I come up here, I'm going to go to Analyze Linear Fit here, or you can use the shortcut here button, which is this one. When you hover, it says Linear Fit, the R equals. And here is my, my linearized model. Now, there's a couple things I want you to notice here. So I'm going to come over here and write a few things down, because I want to show you how you would write down this model, how you would write it down. So if you notice in the box right there, you can see here at the top, it says I equals mx plus b. Now notice that the x variable actually is 1 over the resistance down here. But if you linearize your x-axis, I don't know why, but LoggerPro won't substitute in the new variable for your independent variable. I'm not sure why. So if we start with that I equals mx plus b, this x here is the part that we have to replace with what's on the x-axis, which is 1 over the resistance. So then for the m and the r, I'm going to replace, or the m and the b, I guess that's lowercase b, I'm going to replace it with the numbers that are here. So I'm going to say that I equals, and I like to put my slope in parentheses so I can keep the units with it. My slope is 1.929 A divided by 1 divided by ohms. Now, some of you might be stopping right here and be like, Miss Lonroth, that's crazy. That's lots of stuff. And I know that if I divide by a fraction, I can invert and multiply. And either one of those would be fine. It is a little simpler to, instead of do 1.929 amps over 1 over ohms, it really is the same thing as amps times ohms. But either one of those would be fine. And then for the x value, I'm going to put 1 over r. And then I'm going to add the y-intercept, which my y-intercept is 0.0009861. And that's amps. That is so small that you could replace that with a 0 because it's much smaller when you compare it to all of our data points and to our slope. It's really very close to 0. So that would be my mathematical model. Now for today's purposes, for today's assignment, in your box in the Canvas quiz, all you need to do is write down this slope, which is going to be this right here. And then you need to write down what constant voltage you used. So those two things, and you could do it either way. You can write the slope down with whichever units that you want because they're equivalent. Amp ohms is a little bit easier. And then also in Canvas, it's hard to, I don't know how to find the little ohm symbol. Some of you guys actually had ohm symbols in there. I'd like to know how to do that. So if you know how to put an ohm symbol in Canvas, let me know. But you would just write it out. So I would write down 1.929 A divided by ohm, or ohms for the first line, and my second line would be 2.0 volts, or however many volts it is that you used and kept constant. And that's it for today. I hope everything's going great with all of you. And if you have any questions about any of this or anything else, go ahead and email me, and I'll get back to you as soon as I can. All right, take care. Bye.